In this video, we're going to go over the solution to the InsertAt method. I'm inside my index.js file. I'm going to give myself a little bit of space here, and then we'll add the InsertAt method. So it will take arguments data and index, and then inside of here, we're going to do a little bit of work. So the first thing I want to do is check the case in which our linked list is currently totally empty. So this has been a very common theme throughout many of these methods. I want to make sure that if our list has no elements inside of it, then we should create a new element and point our head property at that new element. So inside of InsertAt, we'll say if this.head does not exist, so note the exclamation right here, then this.head will be new node with the data that was passed into our function. And then very importantly, we'll want to make sure that we immediately return. So let's save this and see how our tests are doing. Back over at the command line, here is InsertAt. It looks like we've got a number of different tests here. So this is now passing our first one where we are trying to insert some data at index 0 when the list is empty. So that was a pretty easy one. Next, we're going to take care of inserting a new node with data at the 0 index when the list does have some elements. So just like the previous one when we used getAt on our removeAt method, or excuse me, the removeAt method that we just put together a moment ago, you'll recall that there was an edge case. If we tried to insert something at index 0, if we tried to get the previous element before index 0, well, there's nothing there. And so if we try using a similar getAt index -1 scheme again, we'll need to make sure that we handle the case that we're trying to get at the element of index 0. So essentially, right after this if statement, we'll say if the index that we're trying to insert at is 0, then we're going to take care of this one manually. So we'll say that the new head, so this dot head, is going to be new node with data. And then remember, the node constructor right here takes a second element, or a second argument. The second argument will be used as the next reference inside the node that is created. So if we pass in here the current this dot head, then we will make a new node that has a next property of the current head. And so if we put that into diagram format over here, it would look a little something like this. We would call new node to form up this orange thing right here. We pass in the current head, which links it up on the next property. And then the last thing we have to do is to make sure that we update the head of the linked class to look at this new node that we just created. And so back over here, that's why we assigned it to this dot head. So for index of 0, hey, pretty straightforward solution. Now, again, we'll want to make sure that if we caught this case right here, this edge case of index 0, we'll want to make sure that we immediately return from this as well. All right, now it's on to our last big case, the case in which we are at some middle element or who knows, whatever it might be. So in this case, we're going to want to try to find the previous element, or the one right before the one that we're trying to add for our new node. So let's imagine that we have index of 2 here. That would mean that we want to kind of displace red. So we're going to try to call getAt with index -1 to find the previous node. So we will say const previous is this dot getAt index -1. So this will give us the previous node. We will then create our new node, and just like we did previously, or just like we saw in that previous corner case over here, when we create this new node, we will pass in the current node after previous. So right now, we just have a reference to previous. The current next would be red over here, right? So we're going to create orange right here, and when we create orange, we will pass in red as the second argument to it. And so that will automatically make sure that orange gets hooked up as, or excuse me, that red gets hooked up as orange's next property. Now blue over here is still looking at red. So we've now got 2 nodes that will be looking at red, but we'll fix up that in just a moment. So back inside my code editor, we'll say const node. So this is going to be the new node that we're going to make. Will be new node. It will contain the data that was passed into our function. And then the next node will be previous.next. So again, previous right here would have been blue. Previous's current next property is looking at red. and we want orange to point at red as well. And so we pass in red as the second argument to form this connection. And then the last thing we need to do is to make sure that previous now looks at the orange node. And so to form that connection, we can say previous.next is node, like so. All right, let's see how our tests are doing. Okay, well, it looks like we've got almost everything passing, but there's still this one test right here that is failing. So the case in which we are trying to insert a new node when the index is out of bounds. So we saw this previously. Remember, this would be the case in which we tried to call InsertAt, with an index of something like 12. So if we called getAt with 12, the value null would be returned. So let's kind of diagram that out and think about what might happen in that case. So I'm going to undo a couple elements here. Let's move this one back over. And then I'll bring on a text element over here to represent null. So if we have getIndex of 12, when we call getAt, we're going to get null returned. And so the previous variable will be referencing null. Now, all of our code is still going to work. Nothing's going to crash. We're going to create our new node, and its next property will be looking at null. So we can kind of imagine that we are in this type of situation right here. But the problem is that red is not looking at orange. Remember that the directions, by the way, had said specifically that if the index was out of bounds, that node had to be added to the end of the list. And that's the case that we're handling right now. So orange will be pointing at null, which is okay. That's what we expect. It is now going to be the last node of our list. But we need to make sure that red somehow gets updated to point at orange over here. So realistically, we really need a reference to red. That's what we really need right now. So one way of handling this would be when we try to get this.getAt index -1, we can say if this returns a falsy value right here, then instead we want to consider the previous node to be the last node of our chain. So let's write that out for a second here. Watch this. We're going to say or this.getLast, like so. So if this function call right here returns a falsy value, then we will go into this or case and we will instead run this line of code right here, which is to say, go and get the last node in our chain. So getLast will be assigned to previous. We will create our new node, and the new node's next property will be previous.next, which had been null as well. And then previous.next will be now updated to node. And so this line right here will make sure that red is now pointing over to orange. So let's save this file and see how our tests are doing now. And we're passing everything. Awesome. Okay, this has been one of the harder ones, especially thinking about some of the different corner cases here. So let's now move on to the next video. We're going to talk about one little extra topic that I just want to throw out there, something that's kind of interesting about our linked list implementation. And then immediately after that, we'll talk about this for each and for of loop implementations for our linked list. So quick break, and we'll come back in the next video.